Okay, now let's discuss the inverse function. So, learning targets. At the end of this lesson, you are expected to determine the inverse of a one-to-one function, find the inverse of the function, represent inverse function through its table of values and graph, find the domain and range of the inverse function, and then lastly, graph the inverse function. Now, when it comes to the inverse function, first we need to recall the definition of a one-to-one function. Okay? A function is said to be one-to-one function if either of the following condition is satisfied. First, for any two elements x sub 1 and x sub 2 in the domain of f, where x sub 1 is not equal to x sub 2, then the function is not equal in the range of the function. Okay, if f of x sub 1 is equal to f of x sub 2 in the range of the function, then x sub 1 is equal to x sub 2 in the domain of f. Aside from this definition, let's recall we can use horizontal line test if we have the graph to test if it is one-to-one function or not. A graph of a function has an inverse function if any horizontal line drawn through it intersects the graph at only one point. Now, in one-to-one function, if f is a one-to-one function, then the inverse of the function, denoted by f inverse, is the function formed by reversing all the ordered pairs in f. So all the values of y will become values of x will become values of y. So note, if the function is not one-to-one, then the function does not have an inverse. Okay, so f inverse does not exist. If f inverse exists, then we have these three properties. First one, the inverse is a one-to-one function. The domain of the inverse is the range of the function, and the range of the inverse function is the domain of the function. Then now, what are the steps? Okay, what are the steps in finding the inverse function? So initially, we have here four steps. First one is verify if the function is one-to-one function on its domain, and then for the step two, here's what we'll do when it comes to finding the inverse function. Interchange the x and y, then solve for y in the resulting equation. And then we replace y by f inverse, and then verify if the function and its inverse are really inverse to each other. Okay, to test that, step number 4, we will use the concept of the composition of the function. Okay, so we'll have f of f inverse of x and f inverse of f of x should have the result of x. Okay, so always remember that the result should be equal to x. Now, let's try to apply steps 1 to 4 to find the inverse function and to verify if our answer is correct. Okay, so let's have an example. The function is negative 3x. So first, let's verify if the function is one-to-one or not. Okay, so we have here negative 3x. Let's substitute x sub 1 and x sub 2. They should be equal so that we can say that this function is one-to-one. So we'll have here negative 3x sub 1 is equal to negative 3x sub 2. Then dividing both sides by negative 3, that is x sub 1 is equal to x sub 2. Which is, it's our conclusion that it is a one-to-one function. Okay? Now, interchange x and y, then solve for the y in the resulting equation. So f of x is just y. So interchange that. So x is equal to negative 3y. Dividing both sides by negative 3 will obtain y is equal to x over negative 3. or negative x over 3. Then replace y by f inverse. So that we'll have now our inverse function. So the inverse of negative 3x is negative x over 3. Now let's verify if our answer is correct. So let's have the composition of the function. F of f inverse x. So substitute the inverse, okay, to the function. So negative 3 times the quantity of negative x over 3. So as you can see here, we can eliminate that negative 3 and that results to x. And then the f inverse of f of x. So substitute the function to the inverse function. So we'll have negative times the quantity of negative 3x over 3. So as you can see here again, double negative, so that's positive, and 3 divided by 3 is just 1. So therefore, we have here x. So as you can see here, both are equal to x. Therefore, our answer is correct. The inverse of negative 3x, the function negative 3x, is f of x, f inverse negative x over 3. Okay, let's try another one. If the function is 5x plus 7. So again, let's start with step number 1. So x sub 1 and x sub 2 again. 5x sub 1 plus 7 is equal to 5x sub 2 plus 7. So here, we can have addition property of equality. Add both sides by negative 7. And that results as to 5x sub 1 is equal to 5x sub 2. Then let's divide both sides by 5. So that's x sub 1 is equal to x sub 2. So therefore, it is a one-to-one function. For step number 2, interchange x and y, then solve for y in the resulting equation. So again, let's interchange. So we'll have x is equal to 5y plus 7. Add both sides by negative 7. So we'll obtain x minus 7 is equal to 5y. And divide it both sides by 5. So we have here x minus 7 over 5. The step number 3, we replace y by f inverse. So therefore, we'll have this. So as you can see, the inverse of the function 5x plus 7 is equal to x minus 7 over 5. Now let's verify if our answer is correct. Again, let's use the composition of function. So substitute the inverse to the function. So 5 times the quantity of x minus 7 all over 5 plus 7. So as you can see here, we can cancel 5. And then x minus 7 plus 7. And negative 7 plus 7 is 0. So obviously that's x, right? So now how about the next one? So substitute the function to the inverse. So 5x plus 7 minus 7 over 5. So 7 minus 7 again is 0. And 5x over 5 is just simply x. Therefore, our answer here now is correct. The inverse of the function 5x plus 7 is x minus 7 over 5. Another example, the function square root of x minus 2. So again, let's verify if it is one-to-one function or not. Square root of x sub 1 minus 2 is equal to x square root of x sub 2 minus 2. So add both sides by 2 and we'll obtain square root of x sub 1 is equal to square root of x sub 2. So let's square both sides. Okay, squaring both sides will obtain x sub 1 is equal to x sub 2. So therefore, it is a one-to-one function. Now, let's interchange x and y, then solve for y in the resulting equation. So x is equal to square root of y minus 2. Add both sides by negative 2, by 2 rather, we'll obtain x plus y is equal to square root of y. So since it is square root of y, we need to square both sides. Okay, and that is y is equal to quantity x plus 2 squared or x squared plus 4x plus 4. Okay, so let's replace y by f inverse. So therefore, the inverse of the function square root of x minus 2 is x squared plus 4x plus 4 or quantity x plus 2 squared. And then next one for step number 4, let's verify if the function and its inverse are really inverse to each other. Okay, so with that, let's substitute. Okay, so square root of the inverse, which is x plus 2 squared minus 2. So as you can see, square and square root. So that's cancelled. So x plus 2 minus 2 is just simply x. And then we have another one. Substitute the function to the inverse. So that's square root of x minus 2 plus 2 squared. And negative 2 plus 2 is 0. Square root of x squared is just x. Okay, so therefore, we are correct. The inverse of the function square root of x minus 2 is quantity x plus 2 squared, or you can expand that as x squared plus 4x plus 4. Okay? Now, what if we knew that the given function is already one-to-one? So let's just proceed to step number 2 and step number 3. Okay, so let's use step number 2 and step number 3 only. So given the function 2x plus 1, so let's interchange x and y. So that's x is equal to 2y plus 1. And then add both sides by negative 1, addition property of equality. So that's x minus 1 is equal to 2y. Divide both sides by 2, so that's x minus 1 over 2. And then for the step 3, let's replace y by f inverse of x. So as you can see here now, we have our answer. The inverse of the function 2x plus 1 is equal to x minus 1 all over 2. Another example, 3 minus 4x. So let's have the process again. Interchange, x equals 3 minus 4y. Then add both sides by negative 3. So that's x minus 3 is equal to negative 4y. Divide both sides by negative 4. So x minus 3 over negative 4. Okay, so now replace y by f inverse of x. So we have here the inverse of the function 3 minus 4x is negative quantity x minus 3 all over 4. And then another example, this is a rational function. Let's try to identify its inverse. So the function is equal to x plus 1 over x plus 2. Interchange x and y. And then let's cross multiply. So that's x quantity y plus 2 is equal to y plus 1. Distribute that. So xy plus 2x is equal to y plus 1. And then combine like terms. Let's combine the terms that has a y. Okay, so that's xy minus y is equal to negative 2x plus 1. Factor out y, so that's y quantity x minus 1 is equal to negative 2x plus 1. Then divide both sides by x minus 1. So we'll obtain y is equal to negative 2x plus 1 over x minus 1. Okay, so therefore the inverse of the function x plus 1 over x plus 2 is negative 2x plus 1 all over x minus 1. Last example, given the function x minus 2 divided by 2x plus 3. So again, interchange, then cross multiply. So that is x times the quantity of 2y plus 3 is equal to y minus 2. Okay, then distribute. So 2xy plus 3x is equal to y minus 2. So again, combine like terms. So that is 2xy minus y is equal to negative 3x minus 2. And then factor out y. So that is y times the quantity of 2x minus 1 is equal to negative 3x minus 2. Then divide it both sides by 2x minus 1. We obtain y is equal to negative 3x minus 2 all over 2x minus 1. So we need to replace y by f inverse of x. So therefore, the inverse of the function x minus 2 all over 2x plus 3 is equal to negative 3x minus 2 all over 2x minus 1.